Hello YouTube, this is J Coder back with another stream. So we're going to be going over the list and mutable list, and this is a continuation from the stream that I did yesterday where we started the code lab about the list, and we were about at section number 4 with the loops. So we're going to go ahead and continue where we left off, and remember, if you want to catch up and want to know what we did previously, you can check out the last video that I did and it will catch you up to speed to where we are at now. But also, I'm going to post the link to the actual code lab so everyone can follow along as well, even on this part 2. And so I'm going to post that in the chat just really quick. And also, without further ado, I'm going to go ahead and mute this music, and we're going to go ahead and get started with where we left off. Also, today and yesterday, we're going to be working on the Kotlin Playground instead of the actual Android Studio. So it's a code editor inside the browser. Since we're strictly working with Kotlin today and not any like UI elements or anything, so we can be able to primarily use this for this code lab. So we just finished up with showing off the while loop, and so we learned that we can do for loops. And so let's go ahead and start with the for loops. A for loop is another type of loop. It makes looping through a list much easier. It starts with the for keyword in Kotlin with the code block in curly braces. The condition for executing the block of code is stated in parentheses. In this example, the variable number is set equal to the first element of number list, and the code block is executed. Then the number variable is automatically updated to be the next element of number list, and the code block is executed again. This repeats for each element of the list until the end of the number list is reached. Delete the existing code in the Kotlin Playground and replace with the following code. So we're going to go ahead and put this list inside our Kotlin Playground, which is a list of names that they want us to prepare so that we are later going to loop through them. Add a for loop to print out all the items in the name list. So we're going to go ahead and add this for loop here to loop through the names. All right. And then it says this is much easier than if you had to write the while loop. The output is this: Jessica, Henry, Alicia, Jose. So actually, when we go ahead and play it, we see that it outputs the names like that for our for loop, which makes things simpler than our previous while loop example. A common operation on list is to do something with each element of the list. Modify the loop to also print out the number of characters in the person's name. Hint, you can use the length property of the string to find the number of characters in that string. So when we loop through, we're going to use the .length method to also print the number of characters that the actual name is. That means the number of letters inside the name. So we're gonna go ahead and modify that here to do this line. So they want to, print out the length inside the actual print statement. So when we play, it says Jessica number of characters 7, Henry number of characters 5. So that's what this code does here as it loops through each um, name inside names. This code This the code in the loop did not change the original list. It only affected what was printed. It's pretty neat how you can write the instructions for what should happen for one list item and the code gets executed for every list item. Using a loop can save you from typing out a lot of repetitive code. Note, here are some other variations of what you can do with for loops, including using them with ranges with specific steps instead of incrementing by one each time. For item in list, a print item, and that will iterate over items in the list. For item in B .g print item, and that's a range of characters in the alphabet. For item in 1.5 print item range of numbers. For item in 5 down to 1 going backward. For item in 3.6 step 2 print item. So this prints 35. Okay, that's interesting. You can find more in the documentation listed at the end of this code lab. A loop is a control flow structure like the if else and when expressions you learned earlier because it dictates a particular flow for how the code should be executed. Now that you've experimented with creating and using both lists and mutable lists and learned about loops, it's time to apply this knowledge in a sample use case. Number 5, put it all together. When it comes to ordering food, a local rest at a local restaurant, there's usually multiple items within a single number for a customer. Using lists is ideal for storing information about an order. You'll also draw on your knowledge of classes and inheritance to create a more robust and scalable Kotlin program. Instead of putting all the code within the main function, for the next series of tasks, create a Kotlin program that allows for ordering different combinations of food. First, take a look at this example output of the final code. You can brainstorm what kinds of classes you would need to help organize all the data. So, from the output, you'll notice there's a list of orders. Each order has a number. Each order can contain a list of items such as noodles and vegetables. Each item has a price. Each order has a total price, which the sum of the prices of individual items. And you could create a class to represent order and a class to represent each food item like noodles or vegetables. You may further observe the noodles and vegetables and have some similarities because they are both food and items and each have a price. You could consider creating an item class with shared properties that both noodle class and vegetable class could inherit from. That way, you don't have to duplicate logic in both noodle and vegetable class. You'll be provided with the following starter code. Professional developers often You'll be provided with the following starter code. Professional developers often have to read other people's code. For example, if they're joining a new project or adding onto a feature that someone else created. Being able to read and understand code is an important skill to have. Take some time to look over this code and understand what is happening. Copy and paste this code into the Kotlin Playground and run it. Be sure to delete any existing code in the Kotlin Playground before pasting the new code. Observe the output and see if that helps you understand the code better. So it wants us to use this code. Um, open class item, class noodles, class vegetable, val noodles equals instantiated with this noodles, vegetables instantiated with that, print noodles and vegetables. And so, gonna go ahead. Actually, let's we can do this. Okay, so there's an open class item, class noodles item, class vegetables item, val noodles equals noodles. Okay. So this is what it prints. Noodles at that, and noodles at that. You should see output similar to this. Here's a more detailed explanation of the code. First, there's a class called item where the constructor takes in two parameters, a name for the item as a string and a price as an integer. Both properties do not change after they're passed in, so they are marked as val. Since item is a parent class and subclasses extend from it, the class is marked with the open keyword. The noodles class constructor takes in no parameters but extends from item and calls the superclass constructor by passing in noodles as the name and price of 10. The vegetables class is similar but calls the superclass with vegetables and a price of 5. The main function initializes new objects instances of noodles and vegetables classes and prints them to the output. Override to toString method. When you print an object instance to the output, the object's toString method is called. In Kotlin, every class automatically inherits the toString method. The default implementation of this method just returns the object type with a memory address for the instance. You should override toString to return something more meaningful and user-friendly than noodle at this address and vegetables at this address. Inside the noodles class, override toString method and have it return the name. Remember that noodles inherits the name property from its parent class item. So it wants us to put this inside the noodles class in order to override. So the toString is going to return the name and okay. And repeat the same for the vegetable class. So the vegetable is going to do the same thing. It's going to override the toString method. And so we're going to add this to our vegetables class. And then it says to run the code, the output looks better now. So when we run the code, we have noodles and vegetables. Because before, you know, the automatic default behavior was looked like just to print the class name and also the address of the class name in memory. But in this instance, we don't really want to print the address of in memory. The next step, you will change the vegetables class constructor to take in some parameters and update toString method to reflect the additional information. Customize vegetables in order. To make the noodles soups more interesting, you can include different vegetables in your orders. When in the main function, instead of initializing a vegetables instance with no input arguments, pass in specific type of vegetables that the customer wants. If you try to compile your code now, there will be an error that says too many arguments for public constructor vegetables defined and vegetables. You are now passing three string arguments into the vegetables class constructor, so you will need to modify the vegetables class. I'll put the vegetables class header to take in three string parameters as shown in the following code. So we're going to update the vegetables class to take in three parameters, which will be the toppings and so we can add the parameters after the word vegetables, which is the syntax here, and then topping 1, 2, and 3, and then we're setting the vegetables inside the main to take in the cabbage, sprouts, and onions. So instead of, that just equaling simply that, we modify it to take in the sprouts and then it says now your code compiles again. However, this solution only works if your customers want to always order exactly three vegetables. If a customer wants to order one or five vegetables, they are out of luck. So, code compiles. And we're not, displaying anything extra. We're not displaying these toppings right now. So, it should compile, but we don't have code to display the actual toppings. But let's see what they say. Instead of using a property for each vegetable, you can fix the issue by accepting a list of vegetables, which can be any length. In the constructor for the vegetables class, the list should contain only strings, hence, the type of input parameter is a list of strings. So this is not the most elegant solution because main you would need to change your code to create a list of the toppings first before passing it into the vegetables constructor. So basically here we are, instead of 3 parameters of toppings, we're going to pass in a complete list of toppings, which can range from probably no toppings to as many toppings as a person desires to add to the vegetables class. So now, instead of adding 3 toppings, and only 3 toppings, we can be able to have a choice to add a variety with a list. So this is not the most elegant solution, because in main you would need to change your code to create a list of the toppings first before passing it into the vegetables constructor. So we would have to do something like this in order to be compliant with the new code, because we're creating a list and then passing it into the class constructor. The class constructor is, inside these parentheses. And so instead of that, we could do a list of these, but they say there's a better way. There's an even better way to solve this. In Kotlin, the var_arg modifier allows you to pass a variable number of arguments of the same type in the function or constructor. In that way, you can supply the different vegetables as individual strings instead of a list. Change the class definition of vegetables to take var_arg toppings of type string. So var_arg so in Kotlin there's a var_arg modifier that allows you to pass a variable number of arguments. So this allows for you to pass in a variable number of arguments, which, note, only one parameter can be marked as var_arg, variable arg, and is usually the last parameter in the list. This code in main function will now work. You can create a vegetables instance by passing in any number of topping strings. So we're no longer using a list, and we're using var_arg instead, which is a special Kotlin feature that says you can pass in more than just one argument if you want, that are known as these toppings. And so to actually do that, we would need to go to the vegetables, and then inside the vegetables we would enter this for the toppings, and this code in main, actually the code in main, I don't need the list anymore to set the properties. And so we can play it, and since we still don't have anything else outputting, but it compiles just fine when we add the var arg. Now, modify the toString method of the vegetables class so that it returns a string that also mentions the topping in this format: vegetables, cabbage, sprouts, onion. Start with the name of the item vegetables, then use join toString method to join all toppings into a single string. Add these two parts together using the plus operator with a space in between. So we can use the join toString, and then so we're gonna have the name of the class space toppings dot join to string. So we're going to go ahead and return all of this for our as our toString function. And then we're gonna go ahead and play that. Actually, I added it to noodles instead of the actual vegetables because we didn't add the var arg for the actual noodles yet. But so when I add that to the name, join with the join toString, it adds vegetables, cabbage, sprouts, and onions. So it adds, vegetables, space, cabbage, sprouts, and onions. Then run your program and the output should look like this. To specify a different separator other than a comma, pass the desired operator string as an argument to join to string method. Example, join to string with a space to separate each item with a space. When writing, so that's convenient if you want to choose how they'll be separated, whether by a space, by a comma, by a dot, things like that, or a dash. When writing programs, you need to consider all possible inputs. When there's no input argument to the vegetables constructor, handle the toString method in a more user friendly way. Since the customer does want vegetables but didn't say which ones, one solution is to give them a default of the chef's choice vegetables. Update the toString method to return vegetable chef's choice. If there is no topping passed in, make use of the isEmpty method that you learned about earlier. So we're going to add this to it. So if toppings dot is empty, then return name chef's the name chef's choice. So I'm going to go ahead and add this to our deal here inside our method, because if it is empty, we want to handle it in this way. And if something is passed in, else we'll go ahead and handle it in the below fashion. With this, with the else, I have this one line, so I can go ahead and omit the brackets. If there's more than one line, I need to add the curly brackets. Update the main function to test out both possibilities for creating vegetables instance without any constructor arguments and with several arguments. So we they want us to go ahead and make two classes of vegetables and vegetables 2, one with a variety of toppings and one with no toppings, and see what happens when we do that. So inside our main class, I'm gonna go ahead and perform that. All right, then. So we have this code now. Let's go ahead and run that. Unresolved noodles. Forgot to add the noodles here. And that noodles will go before the vegetables. We didn't really do anything with the noodles yet. And so let's see what it does. And then so basically if you add toppings to the vegetables class, it's gonna display those toppings. And also if you don't add anything, it will display chef's choice. And I don't even just have to add 3. I should be able to add more than 3. And let's try that. All right. Even the additional 2 I added, it will automatically handle that because we have the var args. And yeah, that's a pretty smooth operation there. And verify the output is expected. I added 2 extra on my own. And then create an order. Now that you have some food items, you can create an order. Encapsulate the logic for an order within the order class in your program. Think about what properties and methods would be responsible for the order class. If it helps, here is some sample output from the final code again. Okay, so the sample output of the final code. You may have come up with the following order class: properties, order, list of items, methods, add item, and multiple items. Print order, primary, include price. Focusing on properties first. What should the data type of each property be? Should they be public or private to the class? Should they be passed in as arguments or defined within the class? There's multiple ways to implement this, but there is one solution. Create a class order that has an integer order number constructor perimeter. And so this class has the order number parameter. So we're going to go ahead and start that off with that. And we're inside our Kotlin Playground. So this is going to be class order. Since you may not know all the items in the order up front, don't require the list of items to be passed as an argument. Instead, it can be declared as a top level class variable. Initialize it as an empty, mutable list that can hold elements of type item. Mark the variable private so that only this class can modify that list of items directly. This will protect the list from being modified in unexpected ways by code outside this class. So it wants us to add this item list, which will be a private list of mutable items. And again, mutable means they can be changed. But private means it can only be accessed by within this class. You cannot access it outside this class. Go ahead and add the methods to the class definition too. Feel free to pick reasonable names for each method, and you can leave the implementation logic within each method blank for now. Also, decide on what function arguments and return values should be required. So after the list, it wants us to create add item and add all and a print method as well, all within inside the order class. So we have that, and then the add item method seems the most straightforward. So implement that function first. It takes in a new item, and the method should add it to the item list. So inside the add item, we're going to add the newly inputted item to our list. And remember to adding to a list, you say .add. And remember, you cannot do a .add unless the list is mutable. If the list was just a list of item, then you cannot call the add method, because that means it cannot be changed. Mutable means it can be changed and added to. 8. Implement the add all method next. It takes a read-only list of items, add all of those items to the internal list of items. Yeah, remember, list means read only. Mutable list means you can read and write to it. So, alright. So this is going to take in a list that can't be changed. However, you can add all of it to the list that can be changed, which is our item list. And remember, when you are adding a list, you use add all. When you're adding a single thing, you use add. So remember not to omit the add all, because when you're adding a list, you have to say all. Then implement the print method, which prints a summary of all the items and their prices to the output, as well as a total price of the order. First, print out the order number, then use a loop to iterate through all items in the order list. Print out each item and its respective price. Also keep a total of the price of of the price of the so far, and keep adding to it as you iterate through the list. Print out the total price at the end. Try to implement this logic yourself. If you need help, check the solution below. You may want to include a currency symbol to make the output easier to read. Here's one way to implement the solution. This code uses the dollar currency symbol, but feel free to modify to your local currency symbol. Okay, so they want us to go ahead and modify our print statement to be able to print the order number. So the order number, the total, well, total equals 0. So this for loop tallies up the total of the actual order, and then it displays the total right there. And for each item in the item list, print the item, which triggers toString to be called the item, followed by the price of the item. Also, before the loop, initialize a total integer variable to be 0. Then keep adding to the total by adding the current item's price to the total. Create orders. Test out your code by creating order instances within the main function. Delete what you currently have in your main function first. You can use these sample orders or create your own. Experiment with different combinations of items within orders. Make sure that you test out all code paths in your code. For example, test add item and add all methods with the order class. Create vegetable instances with no arguments and with arguments, and so on. So inside our function main, we're going to go ahead and run these tests here. So inside our main, we're going to replace this code with this. So this is going to be a sorry. This is going to be our order 1, order 2, and order 3. And so let's see what that's going to print out. And this is becoming a kind of a sizable Kotlin Playground. But that's great because we are getting much needed practice. So it says unresolved variable Tim list, which is a typo, which that means item list. And let's try that again. All right. So we have order number 1, $10, with a total of $10. And order number 2, noodles, $10, vegetable choice, $5, total $15. So it looks like this is a restaurant of vegetable pasta. And so this one would be noodles 10 and carrots, beans, celery $5. So okay, so they don't seem to charge extra for the toppings. So yeah. The output should look like this. Which yeah, that's the output that we got. Great job. Looking like a food order now. Improve your code. Keep a list of orders. If you were building a program that would actually be used in a noodle shop, it would be responsible to keep track of a list of all customer orders. Create a list to store all the orders. Is it a read only list or a mutable list? So add the code. So we need to add more orders later. So it's gonna have to be a mutable list. Add this code to the main function. Initialize the list to be empty at first. Then, as each order gets created, add the order to the list. So it's going to be a mutable list of order list. And then after we execute like this order code, we're going to go ahead and add the order to the order list. So this is order 2. I'm going to add item, add vegetables, and then here they add the noodles and the vegetable all in one. Then add all items, and then add to the order 3 to the order list. So we will put this in our main function. Alright. So we're gonna keep track of our order list in memory here. Of course, with the Kotlin Playground, where we can't store anything permanently. Okay, so as of now, we are not printing anything. So since the orders get added over time, The list should be a mutable list of type order. Then use the add method on mutable list to add each order. Once you have a list of orders, you can use the loop to print each one. Print a blank line between orders so the output is easier to read. So this is where we're going to handle our printing. We're going to handle our printing down here. For order in order list, order.print, and then we're going to print the line there. This removes duplicate code in our main function and makes the code easier to read. The output should be the same as before. So the output should be the same. When we hit the run, we get this output, and this output for $15. Implement builder pattern for orders. So there's a special pattern in Kotlin programming, and you can you can use it inside your development called builder pattern. And I would say you should memorize this if you can, builder pattern, because it might pop up in the future and you might be required to recite a pattern that you have worked with. To make your Kotlin code more concise, you can use the builder pattern for creating orders. The builder pattern is a design pattern in programming that allows you to build up a complex object in a step-by-step approach. 1. Instead of returning unit or nothing, so unit inside Kotlin is the same as nothing, from the add item and add all methods in order class, return the changed order. Kotlin provides the keyword this to reference the current object instance. Within the add item and add all methods, you return the current order by returning this. So we will return the current order inside the add item and inside the add all. So So right now it's not returning anything, which is returning nothing, which aka returning unit. But right now we're gonna return this, which is referring to the updated order, and that returns this. And in the main function, you can now chain the calls together as shown in the following code. This code creates new order and takes advantage of the builder pattern. So order for is order with the for passed in dot add item dot add item. So you can go ahead and chain these items, add items together like this. So all in your initialization of this order. So the order dot add item, and so yeah, you can do that, and they call that the builder pattern. And I would encourage you to also do more study on the builder pattern as well, because you might be asked about that in the future, whether it be in an interview or maybe on the job, possibly. But anyway, we will continue, and says in the main function, you can now chain the calls together as shown in the following code. This creates a new order. So we're going to create an order number 4, which we have like order number 1, 2, and 3. So we're going to create this order number 4 in the special builder pattern where we can use add item dot add item, all in the same line here instead of doing it separately here. Order 4 returns an order instance which you can then call add item noodles on. The add item method returns the order instance with the new state, and you can call add item again on it with vegetables. The return order result can be stored in the order for variable. The existing code to create orders still works, so that can be left unchanged. While it is not mandatory to change these calls, it is common and recommended practice that takes advantage of the function's return value. At this point, you actually don't even need to store the order in a variable in the main function. Before the final loop to print out the orders, create an order directly and add it to the order list. The code is also easier to read if each method call gets put on its own line. So we can say, for instance, for order 5, we can go ahead and say order list.add, and then a new order 5 with 2 noodles and a vegetable. So someone obviously wanted extra noodles. So we're going to add an order number 5 here. And they pass in spinach. They should give you an option for a sauce. Maybe that's a activity that I can assign you all to do as an exercise. Run your code, and this is the expected output. So we run our code, and there's something wrong here. Type mismatch. Inferred type is order, but unit is expected. So, okay, so they also wanted us to modify the noodles actually let's see. Type mismatch inferred type is order, but expected noodles dot add item. So inside the noodles, we also need to noodles the order. Add item. Oh, what is this guy? Order number 4. Dot add item. Dot noodles. Huh. Something. Okay, so we have 5 there. There we run. Dot item. Dot I return this. Return this. The add item. Huh. What? So we had this before, and this didn't work. Okay. Play. Unit is expected. Unresolved method. Which we did. Turn this for the add item. Type is ransom for type is order, but unit was expected. Return this. Inferred. Huh. That was. Could have swore that was just working before. Okay, congratulations on finishing this collab. Now you've seen how useful it can be to store data in a list, to mutate lists and loop through lists. Use this knowledge in the context of an Android app to display a list of data on screen in the next code lab. So this is going to be our source code, and so here we do have the return list at the add item, return this and the return this, and that's the only return this is that they actually want. So it looks like this is what I had, but potentially maybe something was deleted to have it complain like this. But let me post the complete solution code. And then after posting the solution code and then play it. Alright. So yeah, that works. There must have been like a small thing that might have been deleted, but that's how it is with programs. You have to do some investigation, and it could be like a small little syntactical kind of issue. But at the end of the day, this is what it's supposed to look like, and this is the code that we have worked on to be able to implement this lab. So hopefully you learned something. Hopefully this was a good exercise for you to dive deeper into lists in Kotlin. And in summary, Kotlin provides functionality to help you manage and manipulate collections of data more easily through the Kotlin Standard Library. A collection can be defined as a number of objects of the same data type. There are different basic collection types in Kotlin: lists, sets, and maps. The Code Lab focused specifically on lists. You'll learn more about sets and maps in the future Code Labs. A list is an ordered collection of elements of a specific type, such as a list of strings. The index is the integer position that reflects the position of the element, which is my list of sub 2. In a list, the first element is at index 0, my list sub 0, and the list element is at my list dot size -1. So you can put this code or this code to access the last item in the list. There are two types of lists: list and mutable list. A list is a read only. A list is a read only and cannot be modified once it has been initialized. However, you can apply operations such as sorted and reversed, which return a new list without changing the original. So there's the sorted and the reversed. A mutable list can be modified after creation, such as adding, removing, or modifying elements. You can add a list of items to a mutable list. So, mutable, you're going to be seeing methods like add all and add, and these methods cannot exist with a regular list. So, you're going to get an error if you try to access that list name dot add, because that is a read-only list. Use a while loop to execute a block of code until the expression evaluates to false and you exit the loop. So remember, this is the syntax for the while loop, but in this case, to iterate through the list, it is better to use a for loop to iterate over all items of a list. And then finally, there's a special keyword in Kotlin that allows you to pass in multiple variables. So of R's modifier allows you to pass in a variable number of arguments to a function or constructor. So that is something that is good to know for Kotlin. And of course, if you want to learn more There's always these extra learning links at the end. I encourage you all to check them out if you have the time. There's Kotlin collections, overview, list specific operations, list learn Kotlin by example, loop learn Kotlin by example, list of, mutable list of, while loops, for loops, var arg, variable, number of arguments, this keyword, argumented assignments such as plus equals. All right. And that's all we have for today regarding our stream. And I hope you all were able to learn something. And if you like this kind of content, I encourage you to please subscribe to the channel and also like this video. And also, I encourage you to comment on the video or ask any questions that you guys may have regarding this code lab that we're going over. And as always, I encourage you to stay coding. All right. Have